This is block 4 of topic 3. In this lesson, we're going to be able to develop and apply vectors for translations of points in the coordinate plane. So vector is a new term for us today. In order to understand what a vector is, let's look at our translation that we did at the end of the last lesson. Now in this image here, you can see these blue lines have an arrow at the end. So they kind of look like they are rays, but are these really rays as a ray is defined in geometry, which remember it has a definite beginning but then goes on forever in one direction? Are these really representing something going on forever in one direction? And the answer to that is no. We're starting at A and we are ending at A prime. So that is not a ray as we define it in geometry. That is actually what we call a vector. So I want to just show you a little short video clip that you may already be familiar with. You may have seen this movie at some point in your life, but this kind of introduces us to our term vector for today. All right, I hope you enjoyed that. It's not every day in math you get to watch a little bit of Despicable Me, but Despicable Me introduces us to the term vector. And, oh, I guess I need to turn that off. You're like, I will just keep watching videos, Miss Hale. That is perfectly fine. All right, so a vector in geometry and in science is a quantity that has both what? Magnitude and direction. So on your notes here for number 1, you're filling in the blanks. In science, a vector is a quantity that has both magnitude and direction. Now I think you won't have a problem with the word direction. You understand what that means, but magnitude just means that it has a certain length to it, is what magnitude means. So there's a certain length that we're going and a certain direction that we're going. A vector can also be described as a directed line segment. So that is the second part of your notes here on number 1, directed line segment. So it's not just a line segment because line segments have a definite length, but they don't have a certain direction you have to go. So like if I draw segment AB, remember we can name that segment AB or segment BA because the direction doesn't matter at all. It's just this certain length that we're interested in with that segment. But a vector, on the other hand, has a direction that it's going in as well as that certain distance that it's traveling. So we're going to look at a animation here that will help us see what a vector is. So here on the coordinate plane, we have point P. Now we can tell it's graphed at the point 2, 2, but for what we're looking at, we're just going to call it a generic point P and have the coordinates as X, Y. So you can see that that point is traveling a certain distance and stopping, but it's also going a certain direction for that distance when it stops. Still, when it's the image point, we're going to label that with prime notation. So P travels and becomes point P prime. Now notice we went H units horizontally even though we could count and see how many we went on the coordinate plane. We're just going to talk about it generically, h units to the right and k units up. So when we are writing that as a in vector notation, we are going to, I think it's on this slide, of course. When we talk about a vector, we use a bracketed expression. So we went h units to the right and k units up. We write those inside angle brackets, h, comma, k. Now we don't put them in parentheses. When you have letters or numbers inside parentheses, we know this represents a point. And so we don't want to get it confused with an ordered pair that represents a point. So we use angle brackets instead. So when you see these angle brackets, you will know that we're talking about a vector, and that is a translation. So whatever number here is in the x spot, it's telling you to go that number units left or right, just like the x coordinate tells us to go x left or right. Whatever number is in the y coordinate spot is telling us how far to translate up and down, since that's what the y coordinate does. So vector notation is using these angle brackets. So another way to represent that we're talking about point P to go into point P prime is we can say P and then do an arrow showing it's mapping to P prime and put that vector notation on top of that arrow to show what translation is occurring going from P to P prime. But most of the time we'll just write it with the angle brackets. We won't actually show like is shown with P mapping to P prime. We'll just use the vector notation and angle brackets. Now, number 3 on your notes says, does it matter which pair of points is connected by the translation vector? And yes, it does, because that will tell us the sign that we want to use on our in our angle bracket. So let's look at this activity here. This animation will help us see that. So I have this quadrilateral, P-A-R-T. If I go and I translate this quadrilateral here, you can see that horizontally I went to the left. So that makes that number in the X spot a negative number. That denotes that I'm going left. And then I went up, so the number in the Y position is positive, showing that you're going up. Now if I went to the right and down, now the X spot is positive and the Y spot is negative. So it does matter which pair of points is connected. That tells you the direction, which tells you what signs to use in your vector notation. Now notice these are the original coordinates of the points for P-A-R-T. And these, let me move my notes over so you can see this. These are the translated coordinates. We can look here in the coordinate plane to see what the coordinates are, but we can also use our vector to help us come up with these. So remember, this number in the X's spot tells me whether I'm going left or right, and if it's positive, that means I'm going right. So all I had to do is take these X coordinates of my original point and add 4 to them since I'm going to the right. So you can see 3 plus 4 gives me that 7. 4 plus 4 gives me that 8. Likewise, the negative 7 in the Y position tells me I'm going down 7. So all I have to do is take these Y coordinates and subtract 7 to get the Y coordinate of my new point. So 5 minus 7 gives me this negative 2. 3 minus 7 gives me this negative 4. Okay, so the points that are connected are really important. You have to know what you're starting with, which are these points without the prime symbol, and where you're headed toward, which are the points with the prime notation. So going from this point to this point would be a different vector than starting with P and going to P prime. So the points without the prime notation are your starting points. The ones with the prime notation are your ending points. And so that lets you know what direction you're going and what sign to use in your vector. So hopefully that makes sense. If we were starting with T prime, for example, and going toward T, which we would never label it that way, but if we were going from this point to this point, then the signs on these numbers would change, because now I'm going left 4 and up 7. So that would be the vector negative 4, positive 7. But you'll know which one you're starting with because, again, it won't have the prime notation on it. The one you're ending with will have the prime notation. So, number 3 on your notes. Does it matter which pair of points is connected? Yes, it does matter. You need to know your starting point and your ending point so you know the direction that you are headed. It's not like a segment that the order doesn't matter in the points that are connected. All right, number 4 says, what if the original polygon was not positioned in the first quadrant like it was in our animation? So what it's saying is, what if this original quadrilateral had been in the second quadrant or third quadrant or fourth quadrant? It still doesn't matter. You're still going to see which direction you're going to your final image. And if you're going to the right, you're going to make that number in your vector notation, the X spot, you're going to make that positive. If you're going left, you'd make that negative. If you're going up, you'd make the Y spot, which is your K value, positive. If you're going down, you would make that negative. So it doesn't affect what quadrant you're starting in. That doesn't matter. So number 4, doesn't matter what quadrant your first figure starts in. All that matters is the direction and distance that you're traveling to your image. All right, so let's look at question 5 in your notes. Hopefully this will help clear up any misunderstanding you might have at this point. So we're using these answer choices to answer parts A through E. So it says if you start with a generic point, x, y, and you translate it, and these are absolute value bars, h units to the right, then the signed value of h is what? Well, if you're going to the right, remember that means that your h, which in your vector notation is the movement left and right, like the x coordinate is. If you're moving to the right, then that number needs to be positive. So h needs to be greater than 0. That means h is positive. If you're moving to the left, however, then that means your h would have to be negative. So you're going to put h is less than 0 here. And then your k value, remember, is in the y spot. That's your up and down movement. So if you're taking a point and translating it k units up means k has to be what? Positive. So k has to be greater than 0. If you're going down, however, that means k has to be negative. So k has to be less than 0. So a single ordered pair rule for translating a point P, which is your x and y generic point, h units horizontally and k units vertically, is given in vector notation here. You're taking point P, x, y, doing the vector hk in angle brackets to it, and ending up with P prime. In coordinate notation, ordered pair rule, that means you're taking whatever your x coordinate was and adding your h movement to it. And likewise, taking your y coordinate and adding your k movement to it. So if I'm going to take a point 3, negative 2, and I'm going to take it to a new point using the vector 5, negative 1, then that means my new point is going to take my x of 3 and add 5 to it. So that's my new coordinate of my new point would be h. If I'm going to do the vector 5, negative 1 to this point, then that means I'm going to take my y coordinate of negative 2, add the negative 1 to it, so it's going to end up at negative 3. So by performing this vector to that point, I end up at this point. All right, make sure you watch video 2 as well.